All right, I think it's time to get rolling. Hope everybody's doing well. Good afternoon. My name is Bill Daig. I'm a product manager at Nasdaq, and Lenny and I, Lenny will introduce himself later. Lenny and I represent a business, Nasdaq Data Link. We're going to talk to you guys about the data product paradigm and what we're seeing in financial services, being part of Nasdaq, but also I think just a general trend concept for thinking about and the modern data stack. So let's get rolling. So as I said, we represent a business at Nasdaq. It's called Nasdaq Data Link. We are essentially the data platform for Nasdaq. It's the storefront for Nasdaq data, proprietary third-party content, partner data, our own alternative data. Think about it as like the one-stop shop for everything Nasdaq data. So we have all the data standardized into products that are discoverable via an online portal, online kind of marketplace catalog, hosted at data.nasdaq.com. Go make yourself a free account. There's lots of free data on there to interact with. We sell essentially data feeds. Data feeds delivered through standard APIs, interfaces to Excel, plugins to SDKs, et cetera. We have thousands of data sets from hundreds of sources. They're all well documented, QA'd, maintained, et cetera. We have 800,000 users from around the globe, primarily in financial services. Think hedge funds, global banks, asset managers, but we also service individuals, academics, corporates, et cetera. So kind of runs the gamut. And so we have a lot of experience thinking about how do we bring data to market as a product. And so our mission is to help clients answer questions with that data, right? So we sit in a really interesting position in financial services where we get to see, we have a good vantage point into how data is being deployed on the front lines across a variety of use cases, in our clients on, trading floors to, corporate decision making. And we see a lot of excitement in, the potential for how data and technology can drive better business decision making and add value. But we're also seeing that this kind of honeymoon period with data and data science and it's kind of coming to an end. There are some real challenges starting to present themselves as firms try to scale. Okay, this is valuable. How do we do this at scale? How do we do this? Repeat this process hundreds of times. We're seeing things like, data sprawl, data quality issues, consistency, governance, discovery, entitlements, all these things that start to get a lot more challenging as you say, okay, it's no longer a handful of data sets we're bringing in the door, it's potentially hundreds or thousands. How do we scale this and actually start to get value out? So I think some of these issues are starting to hold the industry back, hold us back as we try to progress. And I think there's a good analogy for what's happening here. If we look back to the Industrial Revolution. At the end of the 19th century, during the Industrial Revolution, factories used to be powered by these big steam engines that turned a system of belts and pulleys that distributed mechanical power throughout the factory. And the factory was actually built sort of vertically, so they could, get these belts to, upper floors, sort of built around this central source of power. Well, when the electric motor came out, everybody was very excited. So, obviously a great innovation, this new technology. Factory managers went out and they bought the biggest electric motor they could find, and they ripped out their steam engines and they plugged it into the same belts and pulleys that they were using before. And what happened was they were very disappointed. Productivity did not increase at all, right? Because they're turning all the same stuff, right? If you turn it, faster, a little bit easier to maintain, there were benefits, but it didn't give them the spike in productivity that they thought. How could that be? It wasn't until 30 years later, a whole new generation of industrial engineers, architects, and factory managers redesign the factory and the manufacturing process around the capabilities of the electric motor that they actually started to see productivity increase, right? So instead of having one big central source of power, you have many electric motors throughout the factory powering individual stations, right? That unlocks additional innovation, things like the assembly line, that kind of thing. And you see there's all these complementary innovations that are needed to sort of take advantage of a new technology at scale. I think the moral of the story is that you have to sort of think about what are all the ancillary complementary innovations we need, but it's not just the technology, it's the people, it's the processes, it's the way that value is getting expressed, the way that you're actually manufacturing or producing. All right, so it's partly the technology. So I think if we take that analogy and we think about where we're at now in terms of big data and the modern data stack and deploying data, again, financial services, but I think in many other industries as well, I think we can let's look at that process today. What are the belts and pulleys today for getting a new data set deployed, new data set integrated? Maybe I purchase a product, I want to power a new trading strategy. What do I have to do? Well, first I have to ingest it. After I've done compliance and legal and procurement and everything, I have to ingest it. I have to connect. I have to pick it up. I need to parse whatever file format it's in. Usually it's something weird. Then I need to clean, QA the data, understand the business content, map it to my internal identifiers. I need to document it. I need to understand are there issues in the history, and I need to load it somewhere where I can do something with it. And then I can start the process of actually productionalizing it, getting it to a place where I can start to get some value out of it. So this is, I have to database it, I have to build my ETL pipelines, I have to make sure they're run, they're monitored, they're maintained. And so I have to do all this work, and then finally, at the end, I get to deploy it to the front lines. I get to connect it to a business application, I get to power a new trading strategy, but I have to do all this stuff, all this hard work, and it's just a means to an end. It's completely undifferentiating. Everybody has to do it, and it's not really the main point. It's not really what I'm trying to get at, right? So, this process, it's undifferentiating, and it's super convoluted. It includes a number of different teams and domains. So, you think dev, DevOps, engineering, data science, business owners, right? Subject matter experts, all have to have their hands in here. So either you have a lot of super inefficient handoffs along the way, or you have people wearing multiple hats, right? I hear a lot of stories from customers. I have PMs or traders who are moonlighting as data engineers and cleaning up data, writing Python scripts to power with their analysis. Is that really what you want your investment team doing, right? Is that efficient, right? The other thing that's kind of pernicious about this whole process is it's not like it's not linear, right? It's more like Candyland, right? You get sent back a few steps sometimes. Data's super unpredictable and really messy, and sometimes there's an error. Sometimes I want to use the data in a different way, and I have to go back to the beginning and store it differently. I need to join it with something else. Maybe I was throwing out stuff in my processing. So it's a constant sort of battle, and all of that means the time to value for getting a new data set in the door, deployed to production, and actually driving business is long, and the ROI on deploying new data sets is lower than it should be. So, but I hope you also realize that this is not a tech problem exclusively, right? And I think that's kind of how we're starting to think about things as well within Nasdaq. We like to think about data sets as a product and really apply product thinking to sort of give an abstraction for what are we deploying and what does it mean to have a data set that's ready to be used and accessed. So thinking about this idea of think about the business that we're in, right? We're in the business of selling and deploying data products, data feeds. And so all of the things that you need to have a successful product kind of are implied, right? Constant monitoring, QA, great documentation, metadata, discoverability, entitlements, governance, customer support. All of that needs to be built in. Otherwise, I can't sell and have a product, right? And so I think this abstraction is really powerful. If you think all of that is assumed, and you're able to zoom out a little bit. I think and the analogy I like to use is, when you're trying to build software, you don't have to think about like the physics of electrons moving on silicon, right? There's physics, and then there's electrical engineering, which is an abstraction on top of that, and there's software and things on top of that. Now we have cloud, and conversation around infrastructure as code. I like to think about data as product, right? Think about it at this sort of rolled up level. And this is a philosophy I think we're trying to adopt at Nasdaq across the board, internally for ourselves as well as for products we bring to market. So a little more like what do I mean by data product, right? I think the main idea is to think about what's the end goal, how is the data set going to be deployed, how is value going to get sort of extracted or realized through it, and then apply like product thinking, product with a capital P thinking. What are the standards I need for this thing? What's the MVP for this thing to be customer ready? We're a vendor, we're a customer to ourselves, as well as a vendor to our customers. And so having that empathy and thinking about our mission, how are we helping clients answer questions, helps us think about what are all the things that we should have sort of table stakes, baseline built into how we store, manage, deliver, expose products. Expose data sets. All right, so a data product is a data set, has one or more tables, plus all the other stuff, right? SLAs, documentation, metadata, entitlements, et cetera. So, I think if you think about all of that up front, how do I need to structure the data? What's the business meaning? What's the best representation of it? You sort of get to skip a lot of those steps, and you get to optimize in a different way. So it's taking that customer use case in mind, applying design thinking, and thinking about the finished product. So when we think about the stack, that's what we're trying to scale, right? That's Data Link is a data product factory. That's what we do, a data commercialization machine, right? And so that's how we try to think about our technology and our processes and our people. Because building a product, I'm sure if anybody's ever been involved with launching a product, it's not just a technology thing. There are always people involved. There are always processes involved. There are always going to be people and processes involved. We have a fantastic data operations team. We have product and business experts who are going to need to be there to do the intense work of understanding the content, writing the documentation, doing the transformations. But what we can do with technology is build process and tooling and automation around those to help scale, right? And so that's what we're focused on. And we're not going to scale people. We're not going to scale data engineers. We all know they're few and far between. But thinking about data products at the abstract, thinking about the process holistically, gives us a little bit more of a view into what should our technology do? Where should we be investing our time and our resources? So Lenny, who leads engineering for Data Link, is going to come and tell us a little bit more about how we do that with a modern data stack. Thanks.
Good afternoon, everybody. Wow, it's a little bit bright. Thanks for coming out. So it's kind of a hard pill to swallow, I think, what Bill was saying, that engineers aren't the star of the show. We're really an enabler, right? And what you'll see about the modern data stack, like what's really modern about it is the choice. It's choice, it's scale. And you'll see the no lack of shortage of choice and the scale that what we're talking about, right? So if we dive in, there's really three paradigms that we're talking about. Ease of evaluation and deployment. We're going through an evaluation process for a key component of our stack right now, and it's actually a business person that's driving it. They're the ones that's setting everything up. They're the ones that are managing, getting data, doing all the connectivity. And within a week, they have a POC up and running, and a very sophisticated portion of our platform that they're actually running. We will be working with engineering, obviously, to do the implementation, but we were all fairly shocked that a business person, right, with just basic SQL skills can get so far without having to really tax engineering as we're doing delivery, right? So that barrier to entry for evaluation, for deployment has been really lowered. Right? The other thing you'll find is the number of SaaS and open source options that are out there. Literally hundreds. Every day we see a company that springs up that we're evaluating, taking a look at, could this work within our stack? And then self-service, right? So one of the things that we're really trying to do is how much self-service can we put into the product, into the platform that we can build that enables really anybody in the company to create a data product. Right? We don't want to submit tickets and wait months for an engineer to build a new pipeline. We really want to give that capability back to a business user or somebody semi-technical with low or no code to get that fast time to value, right? And then massive scale, right? I mean, we deal with petabytes of data. Some of it is real time, intraday, end of day, wide, complex. I mean, really just we see pretty much every possible volume, variety, and velocity of data out there. And these platforms have to scale. They can't just work in some use cases, but not all use cases. And then lastly, component-oriented, right? And so what we mean by this is it's a system of systems. And you'll see the modern data stack is about choice and integration. And it's putting these components together in such a way that you deliver a solution, and not only that, there's very low barrier of entry to flip it out, right? If something better comes along, it shouldn't be a multi-year effort to change a significant portion of the system. And it's relatively low risk to do that. And I'll talk a little bit about what we're doing on our data warehouse as well. So, right. No, awesome. There we go. Okay, so layer cake. I'm sure you've all seen this diagram. This diagram isn't really new. I think the slide is probably many years old. But what you'll see in there, right, going left to right, just your classic three-step process, or maybe more at this point. But ingress it, you have to land it, offer services to query it, and then you have to give clients some form of access, right? And so over the course of the last 10 years, this has really gone from a process of building most of this out custom, right? Yes, you can buy a database and plug that in, but all these other layers, in essence, you're building it yourself with custom software, right? And what you'll see in today's modern data stack, it's really not about building, it's more about buying and integrating, and then building just the components of the data stack that add value, right? That's your core intellectual property, right? The data loaders, there's a rich ecosystem of connectors. If you work with Databricks or Confluent, there's hundreds of connectors that companies support and thousands of connectors that are in the community as well. Orchestration, right? Airflows has been around forever, right? Even streaming, Kafka's been around for a long time, right? So you see these open source technologies that are that you can plug and play that get you down the road a lot faster than having to build that yourself, right? There we go. Now it's working. Cool. All right. So the state of the modern data stack. And so when I mentioned choices, this is just a small sampling of vendors that are actually out there. Again, in some of those same categories, right? Object storage. Look how many different object stores there are, right? We just think about S3 or maybe Azure Blob Storage or Google Blob Storage, but you could see there's like 20 just in object store, right? I mean, table formats, right? We heard about the Delta format being open sourced this week, right? But there's no shortage there, right? And then the vast variety of machine learning tools that we're not even gonna get into. But even on the ingest side, right on the left, right, there's 30 different vendors that you can pick. Some of them are managed through the cloud. Some of them are commercially available as well. And many of these are open source and moving quite quickly, right? And you can see Databricks plays, among other vendors, they play in multiple categories, right? So there could be instances where one vendor will actually give you quite a few of the capabilities right out of the box, right? Sort of eases your integration. So it depends on your use case. So this is kind of an eye test, but you can see just the ecosystem. And next year, I'm sure there'll be twice as many companies on here. It's a space that's rapidly evolving, right? So let's take a look at our specific data stack, right? And so as I mentioned, we use quite a bit of open source products and commercial products, right? We're a big Databricks shop. We're a big also, Postgres and Trino shop in the middle for our data warehouse and analytics capabilities. And then Airflows for orchestration and Hive for metadata, right? So you might be looking at that and saying, well, some of those technologies are I don't know, Airflows is probably 10 years old at this point. Kafka's at least 7 or 8 years old, and Postgres has been around for 20. So we grew this, the business through acquisition and organically, but in many cases, these have held through the test of time, right? We introduced Trino to do, distributed analytics for big querying capabilities, and we bolted it onto PostgreSQL. So you can see, like in some of these key areas, like data loaders, orchestration, TCP streaming, we use commercial off-the-shelf, either open source or commercial products, plug them in, and we're going pretty quickly down the road. Where we invested and where we found products that weren't sufficient were in data quality and lineage. So we have a data operations team. We build a series of tools that are bespoke to their workflows. It's a series of tools that looks at data, evaluates data, does quality checks on it, does alerting, monitoring, observability. And just in the last year, I'd say in the last 18 months, this is an area that we're gonna evaluate because there's a rise of what's called data observability. And there's a whole new category of tools now that are being open sourced and commercialized that solve this very problem that we've spent probably about 10 years, maybe more, building tools for, right? So instead of continuing to maintain custom software, we can plug in these commercially available products and free up our data operations team to do much higher quality of work or higher thinking. With the same headcount, with the same footprint, we have more output, and our operational burden also goes down because, as you can imagine, custom-built software has a lot of nuance. If people leave, that tacit information gets lost. So another area actually right now that we're looking at is the data warehouse, as I mentioned. One thing that we've had a lot of requests for, especially in the last, again, probably 8 months, 2 years, is real-time OLAP queries, right? So we want sub-second responses across tables with complex joins, and we want it in sub-second query response times, right? And so, unfortunately, Postgres at scale, it's just not cost-effective. And Trino, we didn't want a separate piece of technology, so we didn't want to manage a portfolio of products. We really wanted one tool. So we're looking at a data warehouse that would solve that problem, a real-time OLAP style database. And to us, this is sort of akin to replacing the airplane engines while the plane is in the sky. It might seem risky, but it actually, because we've sufficiently abstracted out all of the different components, and the components are loosely coupled, we're actually able to flip out a major portion of the platform while we maintain consistent SLAs and while we maintain that consistent user experience. And just recently, less than a few months ago, we introduced Delta Share, and the POC, I think, was just done in a couple of days with some significantly large and complex data sets. And that was a testament to our partnership with Databricks. But the technology is sufficiently advanced that you can do that and plug and play quite quickly. So what did we learn about this process, right? As Bill was saying, treating data as a product drives more value at scale, right? So products are consumed and created via consistent interfaces. We have thousands of data products, tens of thousands of data tables, but one set of APIs, one set of SDKs, and a consistent set of documentation, right? So it's not just about technology, but it's the overall user experience, and treating data as a product, treating data as code, and having a life cycle for it made that possible as well. So the other thing was, using this abstraction, we're actually able to put out data products faster, right? So now we're starting to introduce a lot more self-service tools, low-code and no-code offerings, so anybody in Nasdaq and our vendors can onboard data quickly, right? So we're going from, hopefully, weeks and months to hours and days in terms of getting their products in the marketplace and commercially available, right? So in the modern data stack, enable that abstraction, right? We've got these interchangeable components that we're constantly evaluating. Are they the best of breed? Can they be doing something better at scale, cheaper, better, faster? And we're able to plug them in. Also leveraging the cloud, right? A great relationship with the 3 major cloud providers. It's not always about just open source. The cloud providers do offer great PaaS and IaaS solutions as well that enables this to move quickly. And so we're always constantly evaluating, should we be managing our own, Kafka cluster, for instance, or should we be using MSK or Google Pub Sub as well? And so that's been, it's been challenging to kind of keep up with it, but again, that choice is really important, right? Because you're not really stuck, and the barrier to entry to switch out is pretty low. So we're able to select the best of breed technology. And then lastly, as Bill was saying, the modern data stack is really about people, process, tools, right? The technology alone, there's some amazing vendors that we saw on that slide that do some pretty innovative things, but just plugging that tool in alone isn't going to solve your business problem, right? And it's not going to solve maybe bad processes or some other inefficiency. So you really have to look at this interplay, this dance of all of those functions. So yeah, thank you very much. Open it for questions if there's any. No questions? Okay, we'll be available outside afterwards.
Hello?
Thank you.
I got one.
Oh, yeah, great.
So we're kind of new to the data product space in general. And over here. Sorry. And so one of the things I was curious about, because you guys have been obviously doing this for quite a while, it seems. What did you see with regards to what level of fidelity do you give the data products to your customers in? Like, what was the journey there? Did you guys go through several iterations of, how much refinement you did to the data before your customers would get it? And, how do you choose kind of what to include and what not to?
Yeah, I think Your mic.
Data link as a data marketplace is a little different from other data like marketplace data vendors in that we actually take ownership of the data. So we're not just like a broker, we're not just a matchmaker, we actually take the hard position of we take responsibility for the data. We guarantee its quality, we provide SLAs and provide customer support. So that has forced us to be a lot more thoughtful about what we're putting out the door. And over the years, it's come at the cost of sort of breadth of catalog. And we've been a lot more specialized as a curator of content. So when our reputation is when you buy a product from us, it's high quality, it's reliable, I can roll it into production, I can connect a production system to it. Because I know if there's an issue, I'm gonna get an email, I'm gonna get a phone call from the team saying, here's the issue, here's how we addressed it, right? So I think we've had to be really thoughtful about it just because of the way we positioned ourselves in the market. And it's kind of case by case as to like what fidelity you need. I think it depends a little on the transformations and the use cases. Obviously, like for financial service, point in time is really important. How you handle updates and revisions is really important. So, like I said, we're always applying human judgment to that. We have an excellent data engineering team and a data operations team that are domain experts. They understand data, they understand the use cases, and we'll apply a judgment call in many cases. This is our recommendation. That's always documented and communicated to the clients as well.
Do you see a lot of desire for more of the refinement than what you give? Do you tend to hold back on that, especially for your internal customers, say, like with internal to the company? Because I can imagine they're asking for all different flavors and variants of all kinds of information. How do you kind of draw the line with regards to what you expose, right, and what you then rely on them to refine further on down?
Yeah, our clients run the gamut, right? I was saying we have, individual, we have students in college through to sophisticated quant hedge funds, right? So there is a huge spectrum of, the really sophisticated guys say, give me all the raw stuff, byte for byte, the way it comes in, in the wild, I got it, I can handle it. The number of firms that can do that and want to do that, I think is actually shrinking. In the beginning, that was the edge. I had a process for dealing with messy data. I had a process for doing that. But I think now it's becoming a lot more commoditized as a capability. And so I think people are realizing there's a lot of benefits to saying like, you know what, like you handle a lot of the messy stuff and give it to me in kind of this like, reasonably processed way. The other end of the spectrum is, give me a report that tells me the answer. Right, and so what we do is we're data products, and we sort of draw the line there. We don't do, analysis or dashboards or that kind of thing yet, where we're actually interpreting business meaning. We're really thinking about like what's the content? What is it? It's a series of measurements. But we have to draw that line for ourselves and what makes sense for our business and our customers. So. Yeah.
So what are you using data sharing? Because I understood. It appears Databricks you are using for a loading purpose. You said that delta sharing is something you are using, so I just want to understand how we are able to do that.
Yeah, so the data comes in Parquet.
Okay.
Yeah, and then we have a conversion process that runs daily. We're going to reduce the latency of that, so we'll run intraday or maybe even real time or near real time, and then expose it as Delta files through the Delta Share server, and it appears in the Unity catalog as well for discoverability.
Okay.
And that's integrated with our auth-auth, or will be integrated with auth-auth once we leave the POC, so that a user will have a consistent experience whether they're using the REST API, FTP, Kafka streaming, or the Delta format to access the data.
Okay.
At the end of the day, it's just a consistent experience. We want it's yet another delivery mechanism for us. So that's our intent. Yeah, right now it's just end of day, conversion to Delta.
Okay, got it.
Right, yeah.
Thank you.
So do you have any characteristics that you use to determine if certain use case belongs here? Or in other words, do you say anytime that, okay, this use case doesn't belong on the data platform? Do you do that?
Like, can you give me an example?
Like if some teams are trying to build an operational application because this is the only place where the data is together instead of the applications actually communicating via APIs. Right. So do you use any such characteristics saying, okay, these are the characteristics that we need to check the boxes to tell that this use case belongs on the platform versus this is something that the applications have to deal with in themselves?
So let me answer that a little bit. Maybe you can dive into the business side. So the intent of Data Link is a single data platform for all of Nasdaq. As many companies, either they grow over time, either organically or through acquisition, there's tons of silos, right? Data is scattered everywhere or siloed off and you don't even know. So our intent is really the entire company, regardless of their data product, will deploy it and make it discoverable on Data Link. And that's the path that we're taking. So it will be the data platform for all of Nasdaq, to sort of promote those data silos. So that doesn't necessarily answer your question, but our intent is that, all of the data will be there for discovery. And again, hopefully it promotes, sort of a knock-on effect that other people want to put their data there without having to be mandated. I don't know if that necessarily answers your question.
Yep. I think one other thing I would add to that is because we'd like to think about it like a product. Actually, I'll back up. So we've had to scale our process for adding and onboarding data sets and managing and maintaining them. And one of the things that's allowed us to do is actually offer that process as a service for clients. And that being in market and interacting with clients in that way, saying bring your own content to our platform, we'll manage it for you as a service, has opened up like a lot of different use cases. But all the while we're thinking about what's the end product, right? And we're thinking about the end use case, design thinking and whatever. So I think what's neat about that is we get to go through cycles of iteration. We see, okay, we put content on the platform in this way, here's how it's getting used in the wild. Here's what we can do to maybe pre-process that or transform it or change the way that it's being managed to make the downstream processes more efficient over time. And so I think there's a little bit of a feedback loop. There are probably some things you wouldn't want to do in a platform like ours, but there's a lot that we can do because we're sort of adapting the way we treat the data on the way in.
Any other question?
The third-party data that you get, like FX data from, say, CLS or lending data from FIS or whatever, are you saying that you're actually taking it and then taking ownership of it?
So not from we take the data, process it, we do QA, we sort of are there to guarantee its quality.
But do you physically take it in
yes,
from them?
we database it and deliver it via like our APIs and our interfaces.
I see. Okay. Thank you.
Yeah.
I think that sometimes the new products based on data are getting more integrated with other technologies like blockchain, NFT, Internet of Everything. So I think that this technology and this architecture have to evolve to get a solution, a more integrated solution. And evolving the people, processes, and tools. Are you experiencing this, or what is your vision about this integration of different technologies?
I haven't seen demand from our clients that they want data to be available via like a blockchain or something like that. I mean, we just hasn't been a driver for us in the market. It's something we would be responsive to, but it hasn't been a use case we've had to solve for yet.
Yeah, and even with some of the size of the market data, given the limitations of the blockchain today, you would see it on layer 2 versus layer 1. Market data would, hundreds of terabytes a day, or at least hundreds of gigabytes, every short window. So we haven't seen it, but I think at least what we've heard about is more lineage, right? How does the data change? What's changed about it? Who's changed about it, right? And so full transparency. In not just landing the data, but what happens to it, and that I can guarantee, not saying like a ledger, but guarantee the efficacy of that data all the way through. And if it has changed, who did it and why. So I think the lineage is important, regardless of the source or how it's transformed. That's, I think, going to be critical. There's a question way in the back.
Thanks. I had a question on sort of the last piece here that's been staring at us. The technology is not sufficient, right? Thinking holistically, evolving people, processes, tools. How are you guys thinking about that, given the productionalizing of the data, creating sort of user experiences that are delightful? How are you then driving adoption, thinking about, evolving people, processing tools to make sure that these products are consumed?
Give you an example. One of the things that Lenny was hinting at is this push towards more self-serve. So a big part of the experience of the platform, for most of its life has been consuming data. I come and I get the data sent to me, right? And it's an easy format. I can query via the API. But I think a very powerful sort of the other half of the story is being able to publish data, right, and store it in the platform. And so we've been over the past year investing in what is the tool set, what are the API interfaces, what are the UIs and workflows we can build that enable users who are appropriately permissioned, right, to be able to publish their own content, their own data sets, be able to save their own ETL pipelines into the platform, to sort of complete that feedback loop. So that's an area where I think it'll unlock a lot. It'll bring time to market for bringing new products to the platform. It'll be very, very easy because we're going to abstract away this engineering effort of building an ETL pipeline and make it so that a business user can do that himself, right? So that's the kind of thing we're kind of thinking about and investing in when we talk about thinking about the platform holistically.
What's the lowest latency to the end user and highest precision?
Lowest latency of the data that streams through the platform?
To the end user.
To the end user, between about 100 millis to 300 millis, depending on the time of day and some of the back pressure, but yeah. So Nasdaq for the market data has a ultra low latency, so we're talking about microseconds, 10, 12 microseconds, but that's a completely different domain, completely different price point. And those people aren't interested in 100 millis. But yeah, this platform for the real time, when we say real time, that's generally what we're talking about is that range in the 100.
And the highest precision in the data?
The highest?
Precision, timestamp precision.
Oh, there's some data sets that tick once a month. On the alternative data side, there's data that comes in end of day, once a week, once a month.
But I mean, we do like tick data, like market data, like through
nanosecond timestamps?
Lenny, you would know whether that's nanos in terms of timestamp resolution.
Micros.
Mics.
Yeah. So that comes right off of the matching engine. Yep. It's the same market data.
All right, thanks guys for the
Thank you very much,
presentation.
everybody.
Thank you.
Appreciate it.
Thank you.